Thank you, Leah, and hello, everyone. So as Leah said, I'm going to talk about OpenMined, actually. It's an organization that is creating a bunch of open source libraries in Python mostly to implement techniques in what we call privacy preserving deep learning or machine learning in general. So I'm going to talk about to introduce you to the field very quickly, and then to introduce you to my work with my team there in NLP, which means natural language processing, for those who do not know, which is a field in machine learning, or AI, if we use this term. So before I begin, let me present myself maybe quickly. So my background, so I live in Paris here. I did actually PhD in computer vision. It was not in natural language processing, but today actually computer vision based on machine learning has many of, let's say, the basic concepts that we also use in processing language. So now actually, let's say my day job is computer vision. I lead the team in a little startup here in Paris to analyze images and to detect objects in images and evaluate the quality of those images. And let's say my nighttime job is leading the NLP team at OpenMined, where we are developing this library called Cyphertext. So let me begin by defining to you what is OpenMined. I will share my screen actually. Let me try to do that. By the way, if you have any questions along the way, just post it in the chat, and me or Leah will read it, and I will eventually answer it. Let me find the screen. This Zoom. I have many tabs open, so it might take some moments. So, yeah, that's it. So do you see a GitHub page? Maybe not.
Yep, I see the GitHub page.
Perfect. So this is the GitHub page of OpenMined, which is an organization created by Andrew Trask. He's a PhD at the University of Oxford, and he also works as a researcher in DeepMind. So it's an organization that has an objective to unify all the techniques in privacy-preserving machine learning and deep learning in a bunch of libraries that I'm going to review to you. So the library here. So PySyft is a library that builds on top of known deep learning frameworks such as PyTorch, TensorFlow, and Keras, and let's say augments these libraries with magical power, let's say. So you will be able to do what we call federated learning, encrypted training, and differential privacy with those frameworks, as if you are working with these frameworks. Even if the original framework do not have these capabilities, PySyft just endow them with these capabilities. So as you see here, it's a library for encrypted privacy-preserving machine learning. Now, there are other libraries. I will just show you this one. So it's PyGrid. So privacy-preserving deep learning, actually, it means that you have a company and a computer, let's say in your company, and you have some other clients, let's say hospitals, and they have data. And in machine learning, you create an algorithm or neural network, for instance, and normally you train it with the data. The problem with privacy-preserving deep learning, or the problem of privacy, is that the data sometimes lives at the hospital's computer, and there are laws, for instance, the GDPR in Europe and EPA in the United States and other ones that prevent you from getting the data out of the hospital. So, and if you want to do any machine learning, for instance, if you have 5 hospitals, you need to get permission of for each hospital, and then there are really restrictions. You cannot take the data out, you cannot look at the data. Very, very hard restrictions, actually, which makes machine learning very difficult in this context. So PyGrid is a library that connects, it's a network, actually. It's called PyGrid. It connects your company with these hospitals with a secure network, on top of which PySyft can come and enable you to do machine learning in a distributed way. For instance, you can just send your model remotely to be trained and like get it back. I'll explain it more to detail. So Ciphertext is one of these libraries here. It's quite young library. So it builds on top of PySyft to do natural language processing. So let me now get into the topic. Do you see a slide?
Yes, we do.
Perfect.
So you can do present mode, and that would work too.
Exactly. That's better. Waiting to load. Yeah, I think see the.
There you go.
Slide now. Perfect. By the way, Leah, now I don't see the chat. If anyone asks me a question, would you please notify me?
Definitely.
Perfect. Thank you. Okay, so we call secure NLP or private NLP with Ciphertext, which is the library I'm going to talk about. By the way, if there's any concept you don't know, you don't understand, please let me know. So Ciphertext, as I told you, it's one of the repos we have in OpenMined. So I created Ciphertext maybe in October, so it's pretty young, less than a year now. And then I created the NLP team, which has like amazing people from all around the world, like developing this open source project, contributing. It's really open to contribution for literally everyone. So we've been developing this for like a few months now. And so we have actually, let's say, the contributors that come from everywhere. So this might be of interest to you. And actually, the contributors that are more active, they join the team, the core team, and we meet every week actually to set, let's say, milestones, goals, and like deadlines for our releases, for instance. So this is the team for the moment. So we are 5 devs and 1 documentation contributor. It means he tracks all the development that's being done and creates, for instance, documentation tutorials. Sometimes we do like what I'm doing with you. For instance, at OpenMined, we have what we call like the AMS sessions, like what we call it. Everyone calls this, call it that way. AMS sessions. So he would, for instance, transcribe the session, the important information there. So this is to say that contributors are not only dev. We need contributors for like other aspects, for instance, documentation. And now we are working on creating a research team actually inside the NLP team. So if you are interested in research, actually, you can already join OpenMined as a research fellow. We don't have yet the NLP research, but soon we will have one. Maybe there's 50 researchers now. We have really very competent researchers coming from institutions like Imperial College of London, some of them MIT. We have really very strong people, and we have also junior people, like people that are still in their undergrad years, so they like to contribute to the research activity. So feel free to, if this is interesting to you, to join. So I will start to talk a little bit more in technical terms. I will try to simplify it as possible. And maybe at the end, I will tell you how I joined OpenMined. So Ciphertext. So as I told you, Ciphertext is an NLP private NLP library, and you might ask the question how to use, like why we are creating this library. So there are two main usage cases: what we call secure plain text pre-processing. So this is a step that we always do when we work with text. We pre-process text. I will explain to you why we pre-process text. And the other use case is to deploy the models you create. So let me explain. The first usage case. So in machine learning, private machine learning, you have your company, and as I told you, you have two machines, remote machines. Imagine that Bob and Alice are hospital owners, and they have their own machines. So in machine learning, you create a model, for instance, neural network, and you have data. Here I put tensors, and you train your models usually on your machine. If you have followed any deep learning courses, tutorials, you will see that you will create your model and then you will train your model on your machine. Now, I told you that in privacy preserving deep learning, you cannot do that because the data is not on your computer. So you cannot do that. So the data should still at Bob and Alice machines, and you have the model on your machine. So in order to be able to train this kind of this model in this kind of situation, we usually do what we call federated learning. It means that you send a copy of the model to Alice and another copy to Bob. So the training happens at Bob and Alice. So in this way, you kind of protect the privacy of the data at Bob and Alice because the data do not go out. So you train the first model a little bit and the second model a little bit. And you know, we have what we call parameters or weights in these models. So because they are trained separately, we need to combine them into a single model. Our goal is to create a single model that is trained on all the data, not like one model per data set. So what we do then, we take these copies, these weights, and we get them back to company, for instance, our company, or there are other messages too. And we compute the average of these two models, the weights, the average of the weights. It's called secure aggregation. So secure actually because sometimes you don't aggregate on your machine because it might not be the best security guarantee. You have another machine that is more trusted to do that, for instance. So you do secure aggregation and you do it again. Then the second iteration, you send the model and you aggregate. So this is, let's say, the typical way you do federated training. Now, images, by definition or by design, let's say, they are tensors because images are composed of pixels and pixels are represented as tensors by design. So we don't have a problem here. If Alice and Bob have images, we can just like plug our model or PySyft. Here I put PySyft because PySyft is the library that I told you can augment PyTorch to make it aware of other machines. Because like to tell it I have data, but my data is not on my machine, it's on the other machine. So PyTorch can then do that with PySyft. So images natively are tensors, but once we work with text, actually, the data is no more tensors. It means they are no more numeric, represented as numerical values, as vectors. So, you know, like in PyTorch and eventually PySyft, if you create a model, neural network, you cannot put text in it. Like it needs to be fed with numerical values. So this is NLP. So what we do normally, not only in private settings, by the way, like if you do NLP, the first step, which is a step that does not exactly exist in image situations, you do pre-processing, you transform, you transform the text into a format that is numeric to tensors, actually. You need to find a representation of your like sentence that you need to classify. For instance, if you want to classify this sentence as positive sentiment or negative sentiment, for instance, you need to transform it into a vector, fixed size vector, that you can then use to train your PySyft model. So you need to try, I think I need to get this out of the way. Up. Yeah, so you have string, your goal is to transform it into tensor and then to train. So you need some components, some processing components in order to be able to do that. So for instance, normally we tokenize, we separate a sentence into single words. We then have, I put here parser, but it's like very generic. You can, for instance, sometimes we exclude what we call stop words, you know, the word the, a, and, the words that do not, in the context, if we are classifying sentiments, we don't care about these words because they do not hold much information about my sentiment, my feelings. So we can have a component that removes these words from the sentence, and then we can have some components that convert these words into numbers. For instance, actually some people sometimes provide us with word-to-vec representations, what we call embeddings, which are machine learning models that create for each word a vector representation, what we call the embedding. And sometimes they are available to us. So we can put a component here to just take like a lookup table to, instead of the word, to put the numerical representation. And this way we can have a tensor. So this pre-processing pipeline, it's not like a single one type of pre-processing. You can do any pre-processing you want. Like it's really an open question, let's say. So once you do that, you can train. Now, Ciphertext, back to Ciphertext, I told you it can help of doing that pre-processing. Why it's important? Because imagine I tell you you need to pre-process a sentence to remove certain some words. Maybe sometimes I will ask you to remove entity words. It means that the name of people, restaurants, maybe hospitals, countries. We need to get those out of the way because sometimes they do not have any information, or sometimes because they have identities of people. We need to remove them in the context of privacy preserving deep learning. So at the same time, you do not have the right to look at the sentence. Imagine like I'm telling you, you need to pre-process a sentence, but you can just not look at it. Like it's a completely blind process. So the Ciphertext can help you create these objects locally and then send them remotely to Bob and Alice, for instance. We call it a pipeline of pre-processing components because it's like one after the other. And those components will do their job locally without you seeing the string. They will do the job for you remotely. So this is one very important thing to do in private settings, to send things, to like pre-program them to do like the tokenization, and you give them command like remove like any word that is like entity word. You give them some instructions and you send them to do the job. So this is the first usage case of Ciphertext. Now, once you do this and you train your model, you're happy with it, you need to save these things. So you spend time to create and fine tune the whole pipeline, oops. Now you need to save it somewhere and to provide it as a service to people to use it. So this is what I call the secure pipeline deploy. Ciphertext can help us, and I will show you how to deploy your model to make it available for other people. So here you have a trained model now. You store it in your machine. Now you have other hospitals that come to the scene. So James has a hospital, and he has some medical notes, and he knows that you have a pipeline that can classify patient notes if they have, like, if indicate, for instance, cancer or not. So Ciphertext can help you find that this pipeline exists and deploy it. So Ciphertext will know how to distribute part of this pipeline for pre-processing to get the strings representation, to encrypt it actually, and to give the prediction and to get the prediction back in a secure way. So this is the second usage case. Now, who are the potential people that are going to use Ciphertext? So the data scientists, so this is what I explained to you actually so far. You create the model, you train it, you deploy it. And also it's possible that as a data scientist, you will also create prediction, like create some analytics, like you have many hospitals and now you have a model that can detect cancer, and you will run it on all the data on all hospitals in the world, for instance, and to see how many cancer cases you have. Like, as data scientist, you can use it. And as data owner, you can, as I told you, James can use it for their own data, not any analytics for everyone. Like one sentence, one medical note, like a service. Like if you have a patient at your hospital and you have like some text, and you just send a command to your company and get the prediction. Let me detail this a little bit, like, so more technically, how Ciphertext exactly does that actually. So we have many details on this screen, but I will try to simplify it. So here actually, if like one day you decide to try to contribute to Ciphertext, I will give you like some indications of the internal mechanics, how it works. So as here, the data scientist use case. So you are a data scientist, you are in your company, and you are using Jupyter Notebook, for instance. And here you import Ciphertext as you import any other library. And you can call a method called create. By create, it means that you will start to create this eventual deep learning model. So you create a tokenizer, you create what we call, for instance, stop word tagger, a tagger to remove stop words if you are working on sentiment analysis. You also create a component. So I will show you actually in code how to do this. A tagger that removes all words that are not polar. They don't have intrinsic sentiment, negative or positive. They are neutral. We can remove them. And then you define this pipeline, and once you trigger the pre-processing process, actually. So in PySyft, we have objects like strings and other types of objects, but we also have pointers to these objects, which are also objects, but we can like point to objects. So when you have a data set, the dataset is on Bob, but locally you won't have a copy of it, but you will have an object that points to it, which is an object that tells you there is a string. I cannot look into it, but it lives on that hospital. It's an object that has meta information about the string. Now, Ciphertext can take strings and tokenize them, but it also can take objects that only provide metadata of strings. So this triangle means that it's a pointer. So each time you see this triangle is pointer to string. Here it's a pointer to subpipeline, it's a pointer to doc. So Ciphertext will sense that the real string does not live locally, it lives remotely. So it will send the whole pre-processing part that you define. And actually, it will do more than this. It will sense that your data set is composed of pointers that come from different hospitals. So it knows that it should clone different copies of the same pipeline you define and send a copy to each hospital to do the job. Why we do that? Because if you have multiple hospitals that have the same type of data, it means that if you can train on all these data at the same time, it's as if you have a big data set. And you know, in deep learning, we like data sets because they can give better performance. So in this way, actually, privacy-preserving deep learning actually provides us a way to create big data sets out of multiple little data sets without really mixing the data, because we cannot, it's private, but it's as if we mix it. So let me continue. So you have this sub-pipeline, we call it sub-pipeline class, sub-pipeline object in Ciphertext that's cloned. And then you trigger the pre-processing and you create a doc object. And simply doc object, it just contains the words that are separated from the sentence, the tokens, and only the tokens that are interesting to you. And also the doc has some capabilities. It knows how to transform each token into a number, embedding. So here, after the pipeline runs, you can just request an encrypted version of your the vector that represents the sentence, get encrypted vector, and you put it in a training batch. And here, when we talk about encryption, there are many types of encryption. We are using what we call secure multi-party encryption. It's not the subject of our talk today, but it's an encryption that you can still use for computation. So it's, even if it's encrypted, you can do arithmetics on these encrypted vectors and it works. And you train your PySyft model. Now, once you train it, I told you, you just like, you want to deploy it, you want to save it somewhere. So you just put all the parts of your pipeline, you give it a name, for instance, sentiment1, and you deploy it to your company. And actually, you can deploy many models, and many companies can deploy many models. And this is what we call PyGrid. I showed you like 10 minutes ago. In OpenMined, we have PyGrid, which organizes or creates a network where clients can put their machines, connect them to companies, and companies can create models, and then clients can search for models. Like, you can see it as, the vision of it is app store of deep learning models that protect your privacy completely. So now, this is the first potential user, which is the data scientist. Now let's talk about the data owner. So imagine you are Alice, or no, I actually, the visualization are for Bob. So you, as a data scientist, you live on Bob's machine, and you want to classify your string. You want to search for the pipeline that's called sentiment1. So you do your search on PyGrid, you find it, and then you ask Ciphertext. Actually, as a user, you just, it's a very simple interface. You call classify the string, run this pipeline on my string, and give me the result. And Ciphertext will know how to deploy the whole thing. So it knows that the string is on your machine. So the whole pre-processing part goes to your machine, tokenizes the same, it creates a document, and then the model itself actually stays on the company. So why it does not go? Because in some cases, privacy preserving deep learning, it's not only about protecting data, it's sometimes protecting you as a data scientist, because if you create a great model to detect sentiments or cancer, you cannot just like send it to the people mobile phone or to the hospital. Sometimes the client can be malicious actually and can steal your model. So we need also to protect the model, not only the data, to protect the intellectual property of the company. So Ciphertext can take this into account and leave the model in the company and use it, let's say, as a cloud service in this way. So once you pre-process, you send the encrypted version of your string. it gets classified. The result is encrypted, but it's sent back, and you will be the only one as a user, as a data owner, to decrypt this result and get your prediction, cancer or not, positive sentiment or not. So that actually, with Ciphertext, you will use the whole thing as if you are working normally, and the whole network thing I'm showing you, like putting this on your machine and the other part on that machine, is behind the scenes actually. This is what we are developing as a team. And if you like to contribute, you will work on these parts, like making it the easiest possible for the user and the smooth, the most efficient possible from technical point of view. So why this is important to create such libraries? Because today, actually, privacy preserving deep learning is a new area. It's not a very mature area, actually. It's really new. It's in its early stage. And many researchers around the world are starting, actually, to do research on that. But because we don't have the infrastructure, like real networks, we are beginning to have them, but like they are not that widespread yet. Many people do not have access to such networks. So many, what they do actually, in order to test their model, which is federated learning, for instance, they say, okay, I have a text data set. I'm going to pre-process it and prepare everything as numerical values, but on my machine. I will simulate as if I'm doing this on a remote machine, and then create my model, but all on my machine, but I'm supposing that it's on a remote machine, which works to create the model, like to say, okay, I did this on my own machine, like trained part of it on that file and part of it on that file, and it worked. But this kind of libraries like PySyft, SyferText will allow you to put yourself in real world settings. So what's the latency of the network when you do this? Is it even possible to do it? Like if you have a big model, you are going to send it back and forth. It's even possible, like even if it's theoretically possible to train such model, you need to test it in real world settings to know actually other aspects, not only the classification performance, but also the network efficiency, like traffic and all these kind of things. So this is the first part actually. Now I will show you very quickly how, like what I explained as like schemas and figures, how to do it in our current version in PySyft. So this is quite simple if you are familiar with PyTorch. And then I will show you, if we have time, the new version we are developing now, new release, how it will work. So sentiment analysis. I'm going to show you how to do sentiment analysis. So exactly what I explained. Actually, you have multiple workers, multiple data sets, and your dream is to get a big data set because you can create a better model, but you can't because it's private. Then you use Ciphertext in order to be able to encrypt things and put them in the same training batch as if you have a single data set. So your data set, as I told you, here you are working on your company's machine. These are the two data sets. As I told you, you don't have the real strings, you have pointers to them, the review, which is the text, and this label, 0 or 1, no, negative or positive sentiment. So you have these two data sets that are only pointer to the real data sets. So you prepare the data set that way. So in Python, actually, it's just a list of dictionaries. So each dictionary has two keys, review, as I said, I'm repeating, text and label is the sentiment, and you have many of these dictionaries. Now you are going to create the pre-processing part I talked about. So here I'm just repeating what I said, but I'm showing you how to do it in code. So Ciphertext import. I'm not going to show you all the imports, not to clutter the screen. So you load what we call language model. It means it's a collection of files, let's say, that have this corresponding between word in a vocabulary and its numerical representation. We call it embedding. So we have them. In some use cases, we want to create these embeddings, but here we have people who already calculated this embedding for us, so you use it. Owner me, actually me is an object that represents the company's machine. We call it a worker object in PySyft. So it creates what we call a language model, and to that language model, we will add all the pre-processing components. So here we create this stop tagger. So, you know, the component that will remove all the stop words I told you about. So it means that it will associate to each word after tokenization a label, a tag that's called isStop. And it will have the value of true if it's a stop word or false if it's not a stop word. Actually, the detail here is not like that important. I'm showing you like a proof of concept of how things work. We call this object in Ciphertext simple tagger because these are like simply tag words with some values. We create another tagger that tells if each word, is it polar word? It has like, it tends to have positive or negative sentiment, or like true or neutral, so false, it's not polar. And then we will tell also like the pre-processing pipeline. If you see is stop true, so if its tag is stop true, just exclude it. And same if it's not polar, it does not have sentiment, exclude it because it's not going to help in classifying sentiment. And now we just call add to pipe. So this stop tagger, we call it add to pipe. So we are creating actually this chain. And remote here, it means that we allow Ciphertext to send them to operate remotely, as I told you. Sometimes you can restrict the access. You can tell, well, this component is very important, very private. I cannot send it remotely. We're not in this use case now. And here, well, if you are familiar with PyTorch, this is the part, what we call the dataset object, which is like simply the part that will trigger the pre-processing component. We use it normally in data loaders. I'm not going to stop a long time on this. It's like quite technical. But so let me show you here. You pass to it the Ciphertext object that has all the pre-processing components in its constructor or in its method. Because we are going to get encrypted vectors, we need to pass some encryption primitives. Don't worry about this. And now here is the method in that dataset object that triggers the real process. So we take, you know, one example, which is a text. We pass it to our Ciphertext object and language object, NLP. And so you, as I told you, you get document pointer. So let me show you here. So you have you defined all these. Now, when you call this example review NLP, it means you are calling this pipeline on that string. And it gets tokenized, and you get doc object, but because the doc object has the tokens, it's private, you get only a pointer to it locally. And this is what I'm showing you here. You get document pointer. And on that pointer, as I show you here, you call get the encrypted vector that represent the string. So the doc will send you that. And that's what happened. Here I'm just specifying the encryption primitives, how to encrypt it. And I'm telling it exclude those tokens. When you create the vector that represent the sentence, exclude the tokens that are not stop words and not polar. And then I get the vector that is ready for training. Here I do the same, but for the label. Well, it's not exactly the same. There's no tokenization. It's just like 0 or 1. So I just use encryption. I encrypt it and get pointer to it. Don't care about this now. It's just the label, the encrypted label. And now we can start training. So secure training. So you create a training set. So we define the train object, that the dataset object I showed you. Now we just instantiate it. So one for training and one for validation. And here again, we send the NLP object because it contains all the pre-processing components. So remember, this use case I'm showing you actually, it's about the usage case, which is how to do pre-processing with Cyphertext and how the data science does it. So I'm showing you these two use cases. The data loader. So it's the data loader, actually, it's the one that will continuously ask for one example and the second and the third to create the batch. So I create two data loaders, one for the training set and one for the validation set. And we don't care about like detail. If you are familiar with PyTorch, you will understand. And now the classifier, actually. So it's a neural network, very simple here. It's a linear layer, fully connected layer. So it's kind of logistic regression. So I define linear layer, fully connected network. This is Torch code, by the way, PyTorch code. And activation function, which is a ReLU, and that's it. Very simplistic. And here, notice actually, I will show you some imports. So I import PyTorch actually, as if I'm working with PyTorch normally. The only different thing I do is I import Syft, which is PySyft actually, and I hook Torch with Syft. Torch hook Torch. And actually, this is a magical function call, let's say. It gives Torch magical powers. And then I work with Torch, actually. It's as if I work with Torch, but it has magical powers. I will show you why I say this. Because after you instantiate your classifier, you give it the number of input features and output features too, because it's like binary classification tasks. We can actually encrypt the model itself because the data are encrypted. So when we are going to multiply, the vectors with the model weights, the vectors are encrypted. We call get encrypted vectors. So we also need to encrypt the model weights matrices. So we encrypt this classifier, fixed precision, share. This is how, what we call secure multi-party encryption. We apply this encryption to the classifier. So note that PyTorch, you cannot call this actually fixed precision and share, like create the encryption shares. But Syft actually gave it magical powers here, and we can do it. So now classifier is an encrypted classifier. And now we create the optimizer, so stochastic gradient descent, as if we are working with PyTorch, the learning rate. And we call fixed precision, well, because we are using encryption to do this. And now it's a training cycle. So you call your one batch of data with a train loader. You enter the training mode. You zero the gradients. You call your classifier, so forward pass. You compute the loss. So this is PyTorch. You compute the prediction, the accuracy, backpropagation, optimization step, so updating the weights, and then you log the results to TensorBoard, for instance, to see like the loss curve and the accuracy curve. And you can see this. We don't care about the results, just to show that it works. And I run it with different types of pre-processing. So one time I did not put any tagger, so I didn't remove stop words or polar words. Another time I added a tagger to remove stop words and polar words, like different scenarios. So here you see the number of iterations and the accuracy for training, and same for loss, for validation. And these are the results. Like it works. And now I told you about the deploy. This is work in progress. So now I showed you how to create these pre-processing, and now you train your model. And we would like to do actually is to put also the model in your NLP object. So far we added only the taggers and we train. And now what we are working on in the release Ciphertext actually 0.1.0 is to be able, so here you already saw this, adding the pre-processing components. And now you add your classifier. Don't tell us, these are like some details on how to prepare for the classifier, which are not even sure we are going to do the same thing as this pseudocode. Actually, this part is pseudocode. The other part, actually, I showed you. You can show it on Cypher. You can see it in Cyphertext repo. You have a Jupyter notebook. You can run actually the training for yourself. But this part is not yet really available. It's under construction. So you add the classifier with the same method, addPipe. You call it sentiment classifier. And remote is false here. It means that your model should not quit your company machine. It's very private. Like, as I told you, you want to protect it. You provide predictions remotely, but you don't download it on your client's machine in case they are malicious. And then, so you have your NLP object, which is what we call the language object. Now it has inside it tokenizer, it has a stop tagger, it has the polarity tagger, and it has a classifier, because we added all with the addPipe method. And now we want to deploy it to PyGrid. It means like save it to PyGrid and make it available for everyone. We just call NLP to grid worker, which means which machine. So I'm going to save it to my machine company. And I'm going to call it a classifier. Well, in the release we are preparing, this method, I chose to call it deploy, actually, not to grid. If you contribute to Cyphertext, one day you will see it's not called to grid for the moment. And that's it. So I hope I was clear on the technical details. I'm sorry if it was too much detail for some of you. I mean, technical detail, but I hope you also understood the big idea. So if you like to join OpenMined in general, like to contribute to any other library, like PySyft, PyGrid, there are many projects, many interesting projects. Feel free. Actually, you can go to the Slack channel, so slack.openmind.org, and you will see like a community of 8,000, 9,000 people. And also, of course, if you are working in research on like a master thesis or a PhD, wherever, actually feel free to contact me and also to come to Slack and to see what's happening. And of course, all the news about Cyphertext, I put it on my Twitter channel. So yeah, feel free to be a contributor and to be part of OpenMined. That's my slides. So thank you very much for listening to me. If you have any questions, I can answer them. If not, I can maybe talk to you a little bit about how I became part of OpenMined. Let me go back to the screen.
Yeah, so far we don't have any questions in the chat, but if there are any, feel free to start typing those out. But if you wouldn't mind giving a little bit more background on yourself, that would be great, kind of how you got involved with all of this and your journey with the team.
Sure, exactly. By the way, if you maybe drop something on the chat to tell me how, if it was very technical for you, or like if the high level concept was clear, it will be like good if I can give like more precisions on some parts. But yeah, so the story with me, so as I told you, actually, actually it's my first open source contribution. So I used to work in companies, and like we had Git repos which were like private inside the company, and we cannot get it out. So actually my experience with OpenMined is like 2 years ago from now. It was my first experience, so I'm not that old in the open source community. So the idea, actually, I was always really interested in open source project, but sometimes it's kind of, you don't know where to begin, because like there are like big communities, very often they are working on something very specific, and you don't want to like you don't know how to get into those details, like and become a contributor. So I was focusing on my research. I was actually postdoc in Paris in Collège de France, which is a research institution, and like I was attending a conference, and which is called France is AI, and we were talking about the GDPR, the compliance problems, the security and privacy problems, and there's so yeah, I have a question here, so I will take it. Yashika Sharma, apart from research, what are some industrial use cases where OpenMined libraries has been used? This is a really good question, so I'm going to answer it before finishing my story. Actually, this is a really good question because so privacy preserving deep learning, as I said, it's a very new area. So our focus now is to develop the libraries and to make them ready for production. That being said, we are already working on some industrial use cases. I will give you examples. For instance, in Germany, there are some hospitals that created a network among them and to host, data. The same idea I explained to you with PyGrid. So in Germany, the government actually did it, provided the network and let researchers do whatever they want with these networks. So there are some researchers in the Imperial College of London who took PySyft, the library I told you that give magical powers to Torch. So they deployed that on that network and started to apply deep learning models in a federated way on medical images, for instance. So this is like a real world use case, which is really interesting because it can leverage the immense amount of data we have in hospitals to maybe better detect cancer, like skin cancer or like chest and lung cancer, many use cases. Another use case we worked on during the COVID period, like we're still working on. So this is another thing who's working on this. It's what we call private set intersection, or like tracking. It means that an app that, so in your mobile phone, there are GPS information and some personal information about you, your age, your name. And we want to know actually if you, someone with COVID, for instance, passes by this area and like it sends you a notification not to go to that area. So it's like tracking people. But the thing is that there's a huge security breach in this, like getting people GPS and like names, ages, like their health situations, like very dangerous applications. So OpenMined intervened actually to create an app that does all of this, but in a secure way. Remember, you can just send processing component to people's phones, encrypt all the data, like understand the data, encrypts all the data and get them back to your server, and then you can do the computations. So you can know that someone with COVID is here. You cannot know who is he or she. You can know nothing actually, except that someone with COVID is here. So this is another use case. There are many use cases actually. For instance, smart homes. So this is not now. It's not a use case we currently have, but it's a future one. In world with smartphones and like edge devices, each house is providing information like temperature variations, electricity consumption, water consumption, many information. And maybe we want to predict something about these houses, like electricity bill, like out of like how people maybe behave in this house. What's the electricity bill? So you cannot just upload people information like this from their smartphones to like your company. You need to do these like computations locally in the home, actually on the home's machine, and encrypt everything and do machine learning out of the smart home. So this is another industrial application. Yeah, many of them. If you want to learn more about this, you can really be part of the community. And like, there's a blog post, by the way. It's called blog.openmind.org. I will share my screen just to show you. There are many like tutorials about these different use cases. You can see many tutorials for these cases. In many languages, by the way. I think like, I don't know, like 15 languages or something like this. Yeah, so this is my answer to your question. Yeah, so let me, we have 4 minutes, right?
Yeah, just so you can finish up your background story, and then
yeah. So maybe it will inspire you to start. And actually, some of my colleagues at OpenMined started the same way. So I heard about this community, and I really like the idea. Thank you, Ricky. So like I searched for a meetup, you know, the meetup website. I searched for the meetup, and that community had a meetup. So at some moment, I started to organize that meetup, actually, because it was kind of inactive. So I started to organize it, like to invite some companies who have these problems and get people to where I worked, actually, at Collège de France, and like to let people interact. And like I contacted some people from OpenMined to help me organize these things. So I really started as like organizing meetups and learning about the subjects as other people learned about it. And then I started to look into the code base, and I didn't know much about the code base. So I used to organize meetups with other people that are interested to look into the code base and try to understand and contribute a little bit. Like when I call like a contribution session. So little by little, I learned more about the code base. I started to know people more, and then we figured out this project, and I started working on this library, and it went that way, actually. And people who are in my team, so many of them are students also. So the way they go, actually, they go to Slack, for instance, or to the blog post. They learn about things if it's interesting. They go to the repos, PySyft, Ciphertext. We usually put a tag on issues in the repos, good first issue. So after following the tutorials, they go to these good first issues and start to contribute. They like create a PR, and like if the code is good and everything is fine, we merge their code. And like after maybe 2-3 PRs, if they are still motivated and like if they are excited about the project, they become members of the team. And some of them actually create their own teams and create their own projects and go along that way. That's it.
Wonderful. Well, thank you so much for taking the time to chat through that whole process, but also too just your background as well. And you're getting some thank yous in the chat feature, which is great too. That was super helpful and informative, and we appreciate you taking the time to talk today.
Thank you very much, Leah. Thank you really all for listening to me, and for the thank yous you're sending, and I hope to talk to you again soon. Thank you. Bye-bye.
Everyone have a great rest of your day.